So another question is, so we got some basic understanding about melanin in our different group have different colors. And why do people get tanned? And what are the signal that triggers that?
Yeah, so really important question. And when we say why do people get tanned? I mean, part of it is like, how does it actually happen?
Yeah,
And then
exactly.
there's another
When
question is, why would people actually do this? And in evolution, in the last 10,000 years of human evolution, like where did this come from? So a lot of questions there. It's a very, very important question, and I'm glad you asked it. So we know that the pathway, which is initiated by sunlight, by ultraviolet radiation hitting our skin, and that is ending with the production of melanin, which is the tan, is actually, it's a DNA damage response. It's an injury response. It's an injury response whose output is the production of dark pigment. It's probably not a pathway that evolved for purposes of beauty. We don't know this for a fact. It's very difficult to explain evolution, but it does seem to have evolved in more likelihood to be somewhat protective against the possibility someone would go out in the sun tomorrow or the next day or the next day, because it can help protect against sunburning and really injuring the skin if you live in a very sunny area. And so we think that it offers protection and a benefit by allowing the skin to adapt to the intensity of ultraviolet radiation, because ultraviolet radiation injures the cells of our skin. It damages the DNA, it mutates the DNA. And those are the kinds of events that have multiple outputs. One is a risk of cancer. Another, frankly, much more common than that, is what we call photoaging. It causes you to look older. It doesn't do it the next day or the day after that, but it produces everything from wrinkles and atrophy to changes in pigmentation that will last, that sort of dark, leathery skin, from some people who've been in the sun enormous amounts of time. By the time they're 40 or 50 years old, you can just look at them and you can say, I think this person was a tanner, really, really spent a lot of time in the sun. And so that's part of what is going on. When we think about the evolution of skin pigmentation, we remember that there is one biochemical pathway that ultraviolet radiation contributes to that in evolution many years ago was one of the only ways to get the vitamin D, one of the critical synthetic steps in making this molecule. This is actually an essential vitamin. Our bodies need vitamin D. And back in the day when we couldn't go to the local pharmacy and get a pill that was cheap and effective to replace vitamin D if you didn't have it, sunlight actually was contributing that chemical reaction for that one critical step. And so for populations, our current understanding is that for populations living at very high latitudes where the intensity of ultraviolet radiation for much of the year, let's say in Scandinavia, is very weak, very, very little UV radiation, very little sunlight, the days where there may be minimal sunlight, days on end, those people 10,000 years ago may have very serious vitamin D deficiency. And if you look at the skin of people whose ancestors evolved to live in those areas, they have light skin and they typically don't tan very well. And that has led to the hypothesis that this was protecting every last ray of UV radiation to contribute to vitamin D production. Even if they were getting some risk of skin cancer, and they were, because these are the people who are at risk of skin cancer, it was a little bit lower because the intensity of ultraviolet radiation wasn't that high in those places. And the skin cancers that formed, even if they were fatal, and melanoma unfortunately can be fatal, they tended to be fatal after the reproductive ages of these people. So getting through childhood, when vitamin D deficiency would be fatal if you don't have it, was actually more important if you had to choose the bad outcome. If you could at least make it through vitamin D deficiency 10,000 years ago, you may die of skin cancer in your 30s or 40s. but at least you made it through childhood. Now things have changed, of course, because we have other ways of getting vitamin D that for populations that need it, you can take a supplement which is virtually identical in its efficacy in replacing vitamin D. And on the other hand, the risk of UV has gone up because many of those very light-skinned people have moved away from Scandinavia or high latitude locations, and now they live in, let's say, Florida
Or
or near the
Australia,
equator,
right? And
or
then that's
Australia.
perfect
Exactly.
experiment, yeah.
Correct, exactly. And so these kinds of discrepancies in light skin, dark skin, and UV radiation intensity have led to pockets of very, very severe skin cancer and melanoma outbreaks as well.
So just to summarize, I mean, I think we touched a lot, right? We talked about what melanin is, what pigment, the melanocyte makes it. That's the same cell that can develop into melanomas. And we touched a little bit about the kind of evolution of vitamin D. And so to just summarize for everyone out there, so basically, in essence, due to evolutionary forces, that as human race migrates from lower altitude, let's say, such as Africa, and all the way to Norwegian, Ireland territories, the selective pressure favors to have individuals with a pheomelanin, lighter skin color, because you need more of the vitamin D production to enhance bone strength and musculoskeletal, right? And then and so that is the cause. But you also touched a little bit about the difference between eumelanin and pheomelanin. Eumelanin is the people with a darker skin. Those have more of a pro-oxidative antioxidant, so they protect the skin from UV radiation. In contrast, the lighter skin, the pheomelanins, they actually not very effective. At the same time, upon UV radiation that causes DNA damage, that triggers the cellular machinery to produce melanin to protect the skin. And those pheomelanin is generated actually creates free radicals, oxidative damage that further creates more damage. So you get into this vicious cycle, in essence.
Yes.
Yes. No, I think this is a really, really interesting thing because most people think photo protection using sunscreen is a very just kind of a straightforward thing, right? But there's so much evolution, so much and nuance behind it, and also I don't know if I have time, but I know in the same molecular pathway that generates this melanin production, that's also creates endorphin. And that is also another reason why some people can be addicted. That's why some people, when they stay on the sun, they feel really good about it,